Metal is everywhere. We use it to build our houses, we use it to make our cars, we even use it to make tiny parts in our phones. One of the most important things about metal is its strength. We need metal to be strong so it won't break. Strong metal is important in many industries. Buildings need strong steel beams to hold them up. Cars need strong metal parts to protect passengers in a crash. Airplanes need strong, lightweight materials for their wings. If metal wasn't strong, our world would be very different. We would have to find other materials to build with. This would be expensive and difficult. That's why making metal strong is so important. Two of the most common ways to make metal stronger are forging and heat treatment. Both methods have been used for centuries. They have helped shape the world we live in today. Let's explore each method in detail. Forging is a process that has been used for centuries to shape and strengthen metal. It involves heating metal to a high temperature. The metal becomes soft and pliable. Then it is hammered or pressed into the desired shape. Imagine a blacksmith shaping a horseshoe. The blacksmith heats the metal until it glows red. Then they hammer it repeatedly. Each blow shapes the metal and makes it stronger. Forging improves the mechanical properties of metal in several ways. First, it refines the grain structure. This means it makes the individual crystals in the metal smaller and more uniform. Smaller grains make the metal tougher. Second, forging eliminates internal defects. This further improves the strength and reliability of the metal. Forged metal is less likely to have weak points. It can withstand higher stress and impact. Heat treatment is another way to alter the properties of metal. It involves heating metal to a specific temperature. Then it is cooled at a controlled rate. This process changes the microstructure of the metal. It alters its properties without changing its shape. There are different types of heat treatment. Annealing involves heating metal and then slowly cooling it. This makes the metal softer and more ductile. It is easier to work with. Hardening involves heating metal and then rapidly cooling it. This makes the metal harder and stronger. However, it can also make it more brittle. Tempering is often done after hardening. It involves heating the metal to a lower temperature. This reduces brittleness and improves toughness. Heat treatment is a versatile process. It can be tailored to achieve specific desired properties in the metal. Both forging and heat treatment can significantly increase the strength of metal. However, they achieve this through different mechanisms. Forging strengthens metal by refining its grain structure and eliminating defects. Heat treatment strengthens metal by altering its microstructure. Generally, forging results in a greater increase in strength compared to heat treatment alone. This is because forging not only alters the microstructure, but also improves the material's integrity. It removes voids and aligns the grain flow. However, the specific strength increase achieved depends on several factors. These include the type of metal, the forging process used, and the heat treatment parameters. In some cases, a combination of forging and heat treatment is used to maximize strength. Section 5. Practical applications, where each method excels. Both forging and heat treatment have their own strengths and weaknesses. They are preferred for different applications depending on the specific requirements. Forging is often the preferred method for components that require high strength and toughness. This includes parts for aerospace, automotive, and power generation industries. For example, crankshafts, connecting rods, and turbine blades are often forged. Heat treatment is often used for parts that require a specific combination of hardness, wear resistance, and dimensional stability. Tools, dies, and gears are often heat treated. Heat treatment is also used to improve the machinability of metals. Section 6. The combined approach, synergy of forging and heat treatment. While forging and heat treatment are often seen as separate processes, they can be used together to achieve even greater strength and performance. Forging can create a superior starting material for heat treatment. It refines the grain structure and eliminates defects. Heat treatment can then be used to further enhance the properties of the forged metal. This combined approach is often used for critical components. These components require the highest levels of strength and reliability. For example, high-performance engine components often undergo both forging and heat treatment. This ensures optimal performance under extreme conditions. The synergy of these two processes results in metal parts that are both strong and durable. Section 7, Beyond Strength, Other Factors to Consider. While strength is a crucial factor in many applications, other properties are also important. These include toughness, ductility, hardness, fatigue resistance, and corrosion resistance. Forging and heat treatment can influence these properties as well. The choice of which method to use depends on the desired balance of properties for a particular application. For example, a component that needs to withstand high-impact loads would prioritize toughness. A component subject to wear and tear would prioritize hardness. Understanding the specific requirements of the application is crucial. This guides the selection of the most suitable metal strengthening method. Section 8, the verdict which reigns supreme. So, which method is more crucial for strength forging or heat treatment? The answer, as with many engineering dilemmas, is it depends. Forging generally results in a greater increase in strength. It improves the material's integrity and refines the grain structure. However, heat treatment offers a wider range of property modifications. It can be tailored to achieve a specific balance of hardness, toughness, and other properties. Ultimately, the best approach depends on the specific application and desired properties. In some cases, forging alone may be sufficient. In other cases, heat treatment may be the preferred method. Often, a combination of both methods yields the optimal outcome. Both forging and heat treatment are essential processes in the metal industry. They allow us to create stronger, more durable, and more reliable metal components. These components are vital to countless industries. Section 9, Conclusion. The future of metal strengthening. As technology advances, so do the methods for strengthening metals. Researchers are constantly exploring new alloys, processes, and treatments. Their goal is to push the boundaries of metal strength and performance. Nanotechnology, for example, is opening up new possibilities for manipulating the structure of metals at the atomic level. This could lead to the development of even stronger and lighter materials. The future of metal strengthening is promising. With continued innovation, we can expect even more impressive feats of engineering. These advancements will shape the world around us. From towering skyscrapers to advanced medical devices, stronger metals will continue to play a vital role in our lives.